Let me just get this set up. Hello and welcome if you're watching this in the future. Let me just set up my docs here. Also, I'm actually not showing anything. I know the screen is all black. Should be better now. Also, let's set up this chat here. Yeah, for now. We're not gonna do the Twitch stuff. All right, let me just check out some stuff and then I'll do a short intro. Okay. So, welcome to the stream. If you're watching this in the future, this will be a somewhat slow stream. Um, a somewhat slow stream where I'll work on implementing some shadow mapping. I'm really tired after a long week at work. It's been fairly exhausting at work, so yeah, I might seem sluggish and be a bit slow today, but yeah, I at least wanted to do some work here on the project, so that's just how it is. So yeah, we will look into doing some shadow mapping, at least getting set up for basic shadow mapping. Hopefully everyone knows what shadow mapping is, uh, or at least the basics. Okay, let me just commit this level editor cleanup. There we go. So basically, what we need to do is to create a separate pass where each object is rendered according to the viewpoint of the lights that are supposed to cast shadows. And you basically do it like a sort of pre-pass. So even before this begin frame here, which is the normal rendering, you actually have a pre-pass where you calculate the actual shadow map. The shadow map is, of course, a depth buffer of sorts from the what do you call it, light's point of view. So yeah, we need some pipelines. We need to modify this because yeah, we need some different setup for, or rather, what do you call it? We won't be using the basic shader stuff. We'll use the basic information here, but we won't be creating render targets. So we would probably like a flag, so we can set a blend mode. Let's see, so our blend mode here should just be let's remove this because yeah, we could change this probably. Yeah, I'm really feeling sluggish today. Anyway, so we would like to modify this part of the is that 0? No, it's not. Yeah, we won't be doing a render target, so let's see, we would probably like some different depth stencil information. Let's see. Uh, but actually, mm, we should instead not do anything because the depth stencil information is the same, but I do think that the rasterized state here needs to be something different. Rasterized state, let's see. Yeah, so depth bias is something that we're gonna need if you know shadow mapping. You use the depth bias to avoid what it is, shadow acne. Uh, and you can directly from the GPU get information about the slope of the what is it called? The depth. I can't remember the term, but the slope of the geometry in terms of the actual depth bias calculation. So yeah, we can use the pipeline to get that information directly. Um, so basically, for a pipeline that is possible to do shadow mapping, we want to set some sort of let's see, we want to set a separate rasterized state, and we want to set a render target property. So let's do a const. Let's see. I think that the const bool you use render target should be true. Yeah, uh, because we want to set that parameter. If we would like to not render to a specific render target, but just do the computations inside the pipeline, regardless, because since we're not storing the shadow depth or the depth buffer information for the shadows inside a render target, but inside a depth stencil view or depth stencil buffer. Um, um, then we don't need a render target, of course. Okay, so let's see. We could do something like then a const on sign int rasterize state mode, which also needs to be 0 per default. Okay. And then we copy this inside our definitions. Let's change this so that there we go. And let's copy this directly up here. And let's use render target, rasterize mode. Right. Yeah, we could change different rasterized state information with this flag here. But we won't. Let's just set it to rasterize mode equals this. We will set up our uh, rasterized state. Details. Rasterized state, depth, bias. Let's see, let's just set it to some arbitrary value here. I think it's floats. No, it's int. Okay. Let's see, that's a float. And next, we set the slope scaled depth bias. I think it's called slope scaled depth bias equal to 1. Okay. So that handles our rasterized mode. And if use render target, we will do this. Otherwise, we won't be using a render target, as the name suggest or the method suggests, or rather the branch suggests. Hello. Well, I'm implementing a shadow mapping algorithm. So that's what's going on. Let's see. So we create our pipeline. And we actually, thank you. Hopefully it will be cool. Otherwise, I only have myself to blame. Let's see. Let's create a shadows shader folder, and let's create some vertex and pixel shaders. Exclude from project. Let's see. And hello, Penguin. What's up? How are you doing? Let's see. Vertex shader. Yeah. we will create the exact same vertex shader, although we need a pass data buffer. Let's see, so let's create this struct here. There we go. So this is the start of our, or rather, our our vertex and pixel shaders. Yeah, of course. Well, you only use the Win32 API for creating the window, nothing else. So, yeah, I don't use it to do anything besides that. So, yeah, I'm not really, or also message handling, but that's not a pain. That's really easy, I think. I don't know what API you would use to run a Windows game application besides Win32 anyway. Let's see. Okay, so we create the pipeline. Polygon. Actually, I don't think. I think. Yeah, we should do some changes to the. Let's see. So we clear the shadow pipeline. Well, since I get minimum overhead of just implementing it directly and not doing anything in particular with the API, yeah, I think I'm fine. I mean, the only part of the code where I actually use the Win32 API is for message handling and Windows initialization, and that's it. There's no more Win32 API code in this project. Let's see, so we create those. Let's create a pipeline structure for our shadow pipeline. Shadows. Let's just do PSO shadows. Whoops. And let's initialize it with our device. Whoops. Device. And of course, let's do a triangle. Yeah. I am. I have a full-time job on this side, which really got the better of me this week. But yeah. Are you doing any programming slash game development or something of the like yourself? Let's see, what did I call it? I called it shadows. Okay. And we will create a pipeline with a vertex and pixel shader. I think this, no, yeah, let's see, 17. Let's do a calculator, yeah, programmer, 17. Yeah, okay. So only two. Uh, um, let's do a per vertex data classification. Let's do no render target. Blend mode will be 0 and rasterized mode will be 1. And let's set the name. Shadows, PSO, string literal, yeah. Or not string literal, wide character string, I think. Set rs name. Yeah. Yo, hello, buddy. Yeah, I know. Work has been too exhausting. So, yeah. I really didn't have any energy left. No. I I work within the healthcare field. So, yeah. Shadows, root signature. Yeah, we should change this. So I'm just gonna leave a comment up here. I already did that, so that's not needed to do. Remove the constant root signature changing slash creation for each pipeline. Just create one and store it in the renderer instead. Yeah, it doesn't make sense what I do right now, but yeah, I would have to recreate a bit of the code to do it. Okay, let's see if everything actually compiles or if we get DirectX errors. Okay. It can't open something, I think. Base shadows. Oh yeah, I forgot that. Oh, not the base. The light struct here is not actually imported. So let's see. Let's find it here and add that. There we go. Max lights is probably not defined as well. Let's see. Do we even implement that macro yet? Do we even implement that macro yet? Or is it just a placeholder for future use? Let me close all of this level system. Why did you go there, baby? Uh, Rasterize mode 1, use render target. Okay. Let's see, what was I thinking? Yeah, the macros, of course. Build shaders. Initialize. Well, no, we do not implement the macros yet. Yeah, shader macros, yeah. But we could override that macro in the future. I think 16 lights in terms of shadow mapping are more than enough. We probably just will be implementing a few, maybe, yeah. I think I'll do the implementation for spotlight-based shadow mapping and then a point light or two, since I'm thinking that we won't be using directional lights, at least for now, in terms of how the game is designed, but we could always, um, basically when you have a regular shadow mapping for, what do you call it, spotlights, it's basically the same thing as, or rather, the whole pipeline is actually the exact same thing as directional lights. The only things that change is dependent on what kind of pipeline parameters you set up in terms of the shaders. So you simply change the view projection matrix for the light source according to whether it's a directional light or if it's a spotlight. If it's a spotlight, it works like a regular view projection matrix for a camera, and if it's a directional light, it of course has an orthographic projection instead. So let's see. We create that. Are we allowed to run our program now, or did I miss something else? Okay, we're allowed to run our program. Let's see. At least we do not get any errors, as you can see here. So things are fine. Okay. So our shadow pipeline here doesn't have a render target and uses the rasterize mode of 1. Let's see. Rasterize mode 1. Yeah, we had that. Yeah, we do have some physics. And a UI, as let me just show you. I have created a level editor. Whoops. Why does things look like that suddenly? Did I? Huh. Did I change something per default? Huh. No, that's weird. I changed something somewhere. It's not supposed to look like that, and it didn't before. Let's see. Yeah, the text is all weird here. Uh, okay, let's see if I change this back into into let's see. Now that is weird. Is it because... Huh? I really don't get it. I really don't get it. What's happening? I haven't changed anything as far as I know. Let me just try disabling this. It shouldn't be the thing that makes the difference, but why on earth did I get that bug? I must have changed something somewhere. Did I? No, I didn't change anything here. Huh. Now that is odd. And in here, why on earth did my shader output change like that? I have messed something up somewhere. You could call them that. It's a texture atlas. And it didn't look like this before I started playing around with this, so let's see. Okay. Did I change anything? Did I change anything inside the blending factors? Let's see. Because right now it seems like I might have changed something inside the blend space here. Or what? Did I set it? No. Oh, now I know. Now I know. Now I know. Yeah. I think I changed the parameter order of the pipeline state stuff, and it will overload just fine. Uh, as you can see here, this one here was previously in a different spot. So right now it just sets the user's render target to true, where it's supposed to change the blend mode instead. So if we add a true here, everything will look correctly again. Okay, silly me. Yeah, there we go. So things do look better. They actually look as they should now. Okay. 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 When you change the parameter layout of your methods and you default a lot of the parameters, you end up in situations like that. Yeah, mind you that I'm really, really exhausted, so accidents will happen today. Anyway, we have our shadow pipeline here. Then we want to not initialize another pipeline, but inside our renderer, we would like a depth buffer for the shadow mapping. We will create one. Let's say depth sensor buffer. I'm not sure that we want a. We don't want the depth stencil thingy. Maybe I need to change the pipeline actually because well, D30 depth 32. Okay, so right now we only have depth information inside our depth buffer anyway. We could change that to contain stenciling as well, but we're not really using that. So we will just create another depth buffer with this format here. Let's see. Draw call specifics. Well, actually, this kind of like separation is not entirely valid. Let's see, shadow. Shadows, shadow map. Okay, so let's clean up this. It's fine. We could scope it if we wanted to, but yeah, no need really. Okay. Let's create a depth stencil view for the shadow map buffer. And for shadow mapping, create regular depth buffer. Okay, thanks for dropping by. Nice to have you here. Okay, let's create that. Create shadow map buffer. Depth buffer. MDS shadow map. Initialize as a texture. Let's just do the height and width for now, which means that we can use the viewport and select. And we can also use that description as far as I know. Let's see, device, create, depth, stencil, depth, stencil view, MD shadow map DSV disk and DSV heap get CPU handle number 1 here. Okay, so whoops. Let's see. So that should create our depth buffer here right now as a committed resource. And let's see if everything compiles and runs. Yeah, no errors. Okay. All right. So let's try binding our pipeline here. Um, we want to transition our resource. So let's copy this call here. We also want to transition out when we're done with this part of the pipeline, but for now we don't yeah, we want to do preparation like this, but except for a pipeline that doesn't use a clear color, it doesn't use a render target, and it doesn't have a render target here. Let's see, null pointer. Yeah, so we want to clear up this specific depth stencil, which you, as you might remember, we created the depth buffer for the shadow map at slot number 2, which is corresponds to a 1. We want to clear it, and we want to make sure that I think we can do this and still run everything. Yeah. And we can then bind our pipeline, PSO shadows, bind root signature, D12 command list manager, get graphics list. Yeah, I need to rework this, but yeah, for instance, this part here doesn't need to be called unless it's the first time, unless we change the root signature, which we don't, but we keep on calling that, which is wasteful. Anyway, we bind our shadows pipeline. Let's set a topology as well. Let's set the vertex and index buffers to be our stuff from before. Let's see. Actually, I think we can move this up here That's some generalized code, right? Yeah. Yeah. We should refactor all of this. Also, I think the rendering pipeline will be refactored a bit more whenever. Yeah, that's nice to hear, man. How's it going? Okay, and let's copy these draw calls here. For instance, let's see if that compiles. It does compile and it doesn't complain. Okay, let's check out. First, I need to update some stuff inside the release version of the game here. We need the new shaders in our release directory. Otherwise, we will run into problems. Do you mean in terms of the project? Because I was asking. Well, I guess I was asking you both in terms of the project, but also in general. But yeah, in general, I'm really, really, really exhausted after a long, hard week at work. And in terms of the project, yeah, well, I guess it's going all right. Okay, let's capture a frame here. Let's see. Depth stencil buffer. Yeah, I didn't name it, I think. I think I'm gonna name it first so I can look it up. Depth stencil buffer. Let's see. Oh, you already have rendering and everything set up, or what? Oh man, seems like you're really far if you're working on guns. That's great to hear, man. Hello. Okay, let's close this. No. Shadow depth buffer. Uh, okay. As you can see here, we have some depth information. Since it's a perspective uh, um, based matrix computation, this kind of result is to be expected. If it were an orthographic um, projection instead of the camera-based one, uh, we would see some different depth information. Hello, hello. But this is actually how it's supposed to be. So Hello. So for shadow mapping, hello. Lots of people tuning in on Twitch. I don't know what's happening. I never had so many people drop by on Twitch before. Uh, oh my god. 32. Oh, I just got raided. Whoa, what? By who? Hello. Hello, everyone. Oh, okay. So, TCAP1. Thanks for the raid. Okay, you just want to see me do some code? Well, let's see if I can provide that. Uh, so now we have actually rendered out our depth information here to our shadow buffer, um, where the algorithm draws every static object, and you can actually see the outline if your color allows it. See the outline of a wall. Right here in the depth buffer. So it seems like everything is working correctly, but we need to change the what do you call it? The view projection matrix of the lights, because shadow mapping is in general based on rendering the whole scene to a depth buffer from the light point of view. Yeah, so we have our lighting information. I think I created in the level here. Yeah, I think we create basic lighting. Yeah, create lights here. So we create one light, which is the spotlight that we see. We need to calculate a matrix. Um, from the what do you call it? Create metadata. We could do it inside the transient data update here. So in here, from the past data itself, we would store the view projection matrix in here. In general, we would store. We don't need this information stored. So maybe I want a separate buffer. Yeah. We could do something like shadow data. Oops. Where we simply store the view projection matrix. Yeah, which would also allow us to clean up our code a bit in terms of shadow pass data. Let's do like that. Then we can clean up our shader code. I don't think we need the lights anymore. We just want the view projection matrix here. There we go. Well, it's just because it was what I got started with, and since I'm developing for Windows only for now, yeah, I decided to do it in DirectX 12. There's not really tons of deliberation on the whole subject um, on my side. I mean, DirectX and Vulkan are uh, almost the same, so once I get good at DirectX 12, I can easily, or quote unquote, easily transition into Vulkan if I want to. Okay. But yeah, sometimes you just end up doing stuff without really knowing why. I also heard that since this is the first time I actually work with a graphics API, um, that Vulkan was a bit more verbose and yeah, tiresome to get up and running. So yeah, not that DirectX 12 isn't verbose at times, especially when you don't use the helper library. Okay, so let's create a small buffer here, like this one, pass data buffer. Um, all right, buddy. Good to see you dropping by. Be sure to post a video on the Discord server in terms of your project progress. It sounds really great that you have gotten that far. Pass data, shadows, buffer. Let's just do this for now and create one of these. Uh, size off, and then shadow. Yes, on the upload heap. And the resource state is just gonna be generic read. And we will set a name and pass data shadow buffer. Shadow pass data buffer. And it needs to be a wide character string here. Okay. So now we have our um, buffer for uploading a view projection matrix. Since you could animate lights, um, you could do what do you call it? Specific computations for this every frame. Yeah, I think outside of this, I actually shouldn't pass in a pass data pointer. I think the application layer would like something that is more intricate, and this should be just a renderer based data type. Yeah, but I can do that in the future. Let's see. Separate level data from renderer pass data structure. Yeah, so this is system calls. This should also be that's not valid anymore. Well, actually I have to do it right now, I think, because yeah, I want to be able to pass in more complicated data into the rendering pipeline and translating it into a set of object data or pass data. Yeah. So this should be something like scene data, right? Or level data. Yeah, and then it should be translated into this. So let's do something like that inside our game object data here. Maybe it's just a level type that we want. So inside this namespace here, we could do something like level data. Level frame data, actually. Although I would prefer not to having to include this level system here inside the renderer, and because whenever I change this, then the renderer header needs to recompile, and yeah, that's just not nice. So let's store it inside our game object data header here, and we will simply copy some stuff. Let's see. For instance, we will simply copy this as a start. Hello, welcome. How are you? Let's see. There we go. This will change, of course. That's great to hear, man. I'm really tired and have a lot of brain fog. Had a rough week at work, so yeah. But I'm trying to keep on trucking. The show must go on, as they say. Okay. On DC? Yeah, I have a Discord link in the description, I think, or at least somewhere on the channel. Okay, so right now this will translate directly inside our application layer where we pass the data itself. We need to change the data type. Where did we actually create it? Up here. There we go. Okay, so thank you very much, man. Okay. So yeah, we initialize one whenever we call this method on the camera where let's see, so I got distracted a bit. I easily get distracted today. So we create the frame data. It's basically the same as before. And we pass it along to our renderer right here. But now we can extend the fields of this data structure here. So whatever we fill out, let's see. All right, buddy. Thanks for dropping by. It was nice having you. Sure thing, man. I'll try. Okay. So where is the error? Let's find it. Lights unknown override specifier. Inside, yeah, okay, so I need some kind of light data structure, which is actually also a renderer type. I have imported that out of the yeah. Let's see. If I move this, do I? No, I don't include it. Okay. Uh, we could do something like just pre-declare it. Drug light data. Well, no. Okay. Yeah, I want to decouple the light data as well as the excuse me. So this is like our world information. So we can at the application layer handle all different sorts of information. We have rigid bodies. We have yeah, I don't know about characters. Are we actually using that anymore? Let me try disabling this. I'm pretty sure we don't. Anyway, we have bounding volumes. We have transforms. We have meshes, materials, all different kind of stuff. But we should also have something called a lights. Let's just do what we just did in terms of creating some light information. We will do like that. Lights. Let's see, it doesn't really care because it just copies the data through a mem copy, so nothing really changes. Let's see, get light data. Let's see, get lights. And let's change the underlying structure here of the lights. It also makes more sense that we have some lights and not only light data, quote unquote. I know that it's basically the same right now, but I like the decoupling of the data. Create lights, light data, lights, temp light. Okay. Let's see. Character. I'm pretty sure I'm not even using this part of the physics system anymore. Whoops, not like that. There we go. So we're back in business. Everything works fine. Okay. So we have cleaned up that part of the process. So as long as this contains the same information in terms of the first part of the struct, this will map directly and it will simply truncate whatever follows since we only copy this range of bytes, which means I can do extensions to this. I can create a GXE G matrix array view projection for this. For instance, we can create arrays of view projection matrices. GXE math get id. Let's see. We pre-initialize it as an identity matrix. All right, and everything should still work fine. Well, it doesn't. Well, let's see. Okay. It obviously doesn't want to do that, so let's just pre-initialize it as 0. Wait a minute, I can't. There we go. Anyway, let's only create one for now. Uh, uh, okay, does it really want me to store a pointer anyway? Oh, wait a minute, wait a minute, wait a minute. This is, of course, lights, view, projection. There we go. Of course, change the name of your types, or rather fields. Anyway. Already did the disclaimer that I'm really tired, so bear with me. So now we could do something like memcopympass get memory here and pass that to a byte pointer where we simply add the size of the pass data here. And then we copy from, or rather, this is actually not the byte pointer. This is just the index, but this is supposed to be the byte pointer data plus size of pass data. And then we want to copy as much as size of we can do like this for now, projection. So if yeah, we have a projection matrix anyway. So this means that we copy whatever is left in this field, in this struct here, after whatever we copy to the pass data buffer. And that means this one potentially times 1 right now. Hard-coded to 1 lights. Okay. This should be fine. Okay, let's see our inside render doc. Let's load the last settings here. And let's see. Okay, so we have a shadow pass data buffer. Let's see, at least object data. Yeah, the identity matrix gets stored, but it's not containing any different any more values than that. So it does as it should. Okay. So now we have uploaded whatever light matrix we want to use. Let's see. So inside our rendering step here, shadow pass to depth buffer. First we bind this stuff here. Bind basic viewport and sysrect plus descriptors, descriptor heap, and then we have our shadow pass to depth buffer. Let's collapse this into a scope. Let's see, UI drawing, end of UI drawing, debug. Let's see, let's redo this. Debug pipeline. Let's put that inside its own scope. And let's do polygon, polygon drawing pipeline. So this gets scoped. Start drawing to render target. End drawing to render target. Let's do this and let's remove this end stuff here because now it's scoped. We already know that it's ending. Okay. That's a bit easier. Let's scope this. Swap chain and command Q and lists. There we go. We will, of course, refactor this whenever a more generalized scalable pipeline is to be implemented. Anyway, so we do our shadow pass here to a depth buffer. We need the pipeline, of course. We don't need to bind the root signature, but we'll do it for now. Or at least maybe we could bind it once and then we don't need to do it during any of the other pipelines since they use the same root signature. I don't think swapping the root signature does anyone any good, so therefore we will try to avoid that. Anyway, let's see. So we bind our shadows pipeline. Yeah, this should actually be called bind pipeline as well as root signature, but it doesn't. Okay. We could just rename it real quick. Okay, bind PSO. Let's see, bind PSO. So now we know that we not only bind the root signature, but also the pipeline state objects. Just for future reference, so that we know that we need to delete the root signature part. Okay, so this is general pipeline stuff. We set our viewport and sysdirect. We bind our descriptor heaps. Um, and then we set up the shadow pass using the shadow pass buffer. It's kind of like a pre-pass. The normal rendering pipeline needs the shadow depth, or rather the depth buffer from the shadow pass, since we render the whole scene according to the lights. Hello, welcome. Nice to see you, Rengoku. We set our depth stencil. Um, yeah, yeah. It's been really nice. I am really humbled by all the viewers who decide to drop by and stick around. Especially a day like today where I'm really brain foggy. So we clear our, we find our handle to our descriptor, or rather a depth stencil, which is specifically bound for the shadow pass. We clear it, and we tell the pipeline that we don't want a render target, so we can simply skip the pixel calculation of the pixel shader step. We could do some clipping of semi-transparent objects in terms of whether they should cast a shadow, but yeah, we can implement that later. Anyway, we bind a pass data buffer, which we need to change because this is the old pipeline. This should be the pass data shadow buffer. Instead, we bind the materials, even though we don't need to. At least for, whoops, this needs to be bound. The materials, we don't care for now, at least. All right, and these transitions states here should be set up here. Transition into no, this should be set up here. Whoops. In the future, transition into a depth right state, because we want to have this resource here be used in several parts of the pipeline. It will be used as a depth buffer for this pass here, but later on it will be transitioned into a resource, a texture resource that can be read from the other, what do you call it, pipelines. Yeah, okay. So okay, I didn't change that one. I see. Pass data shadows buffer. There we go. Okay, let's see what our program actually decides to render to the depth stencil. Okay, let's load this level and let's move closer to something. Maybe even look at something. Well, since we're not using the camera anymore, nothing should show up. Let's see. Anyway, whoops. Okay, I can't close the application. There we go. Or what? Okay, it just closes the application and stores the data. Okay, that's fine. So let's see. We have a shadow depth buffer, which probably doesn't view contents. Oh, okay. Um, it does show some information. That's the swap chain. Okay, yeah. So it can't calculate the vertices and so forth. It might even think that it's inside something. Yeah. But at least we get an output here. We need to compute the viewpoint of the lights. Big command list, let's see. And our depth buffer, normal version here. Well, of course I clear it, so I need to let's see. So yeah, as you can see here, the depth buffer gets filled out with the information of the whole scene here before I clear it and draw the debug information. So this is basically our depth stencil here before. And let's see, our depth pass here doesn't get computed because it doesn't have the correct matrix anymore. Okay, so what are we gonna do? We're gonna do something like we do for our camera, except that we will do it for our lights. So if we look at our camera here, we have some functions where we can create a view matrix. Where we have a position, a looking direction, and the right and up vectors. And from that we calculate the view matrix. In terms of the projection matrix, we specify the near and far plane and so forth. So basically we can simply copy all this stuff here for our lights because we're basically creating a camera. Let's see, let's close all of this which got opened whenever I did a lot of the other stuff. Okay. So we have our level frame data up here. We store our delta time, we get our lights, we get our camera data as our initialization data. Let's see. Calculate view and projection matrix for our lights. Right now we only have one light, hard coded. to one light. And actually, I want to see inside our level system here what light information we have. We create a light with these what do you call it, parameters. It's a spotlight. It is our lights right here in the center of the scene. Right here, you can see the spotlight. So this is a dynamic object which we don't do shadows for right now. So this is a static object, so it's supposed to cast a shadow. But let's see. We will create a G matrix, math, G matrix. Is it just inside the, it's not inside the namespace, it's just inside the GXE space. Okay. Projection, which will be our math matrix. Projection, right-hand sided thingy here. And I can't remember what FOV we actually use for the camera. Inside the camera controller, cam up, cam FOV angle. We created inside our application, probably, don't we? M cameras, build resources. Okay, we have our FOV right here. Okay, I need to jump up here. And then 16.0 divided by 9. Let's just do that for now. And then 0, and then 15. Let's do the drop off, fall off end thingy as the far plane. Okay. Then we do data lights 0 position, which is a G float 3. So negative cam position here. We will negative light position, math store load 3, and we will load the position of the lights. Passing the address of that. Okay. Huh. So yeah, we have a problem in that the direction of the light is actually a negative on the y, meaning that we cannot directly use these parameters here. So direction of look is supposed to be our um, let's see, not position but direction. Let's see, strength doesn't matter too much right now, I think, because we will manipulate these variables here. I think it's related to the near and far plane calculation in terms of the fall off and so forth. So yeah, I can't remember how we actually calculate spotlight, um, but we will fix that. Okay, so our direction of looking is the direction of the light. Then we actually want sort of a up direction or a right direction. Um, yeah, we can still calculate it because I think when we cross the real world up vector here, let's see, cross product of two opposite vectors. Yeah, okay. Yeah. So we would end up in a situation where we would have a zero vector if we just crossed the direction of looking with the upwards y. So so, well, if we rotate something so that it's looking down the y-axis, I'm thinking that the up direction would be negative c then. Let's see. Let's try that. Yeah. And then the up direction is, of course, just the cross product between this. So this would be a vector that two vectors, one is pointing down towards the negative y, and the other is pointing outwards, meaning forward into the screen along the negative z-axis, which means that the cross product of that would be probably a regular x-axis. Yeah, so this would be the x-axis. We rotate forward, and the up direction will be actually going along the negative z-axis. Yeah, we don't need to do this, but in case we rotate it or something like that, yeah, we could do the dot product between the up direction. If it's -1, we can't do the cross product thingy. Yeah, we could do some checks here. Could do a more robust code. Could automate this with more robust code in the future. Okay. Let's see, and then we simply create a view matrix from all of these. Negative light position here. And let's do a G matrix view. There we go. So we create our view matrix. Then our data dot lights view projection matrix here gets equal to our projection light times view light. Okay. Let's just try that for now. Because we should automatically upload that. There we go. And let's see render doc. What am I gonna get? Shadow depth buffer. Oh, it might be cleared as well. Let's see. Depth only pass one. Let's see. This is here. And inside our pass data buffer here. Well, maybe. So we do have a sort of problem here. Let's see, can I just look at the data itself from the textual viewer here? View contents unbound. Okay. Let's try doing, oh, wait a minute. Well, maybe I'm not calculating that matrix correctly here. Okay. Let me see. So the position. Huh. Let's print register direction of loop. Right. Up. And then just a space. There we go. Let's see, direction of look. Well, yeah, okay. It's of course negated here. I don't think we should negate it here for the camera. Should we? This does look a bit more reasonable, I think. Let's see, render doc. There we go. So we get something more reasonable at least. At least. Anyway, I think I want to try to create a camera. Right now we have our free floating camera here. We also have the pole camera. If we temporarily swap out the pole camera here, but instead set it to something like our lights here. So let's see. Let's see, -1 here. What happens if we do something like that? Well, It doesn't change anything. Position 12F. Let's do something absurd. Hello, buddy. Nice to hear. You should do a video of your project. By the way. Doesn't he even not use? Maybe it doesn't. It literally just doesn't change anything. Huh. Alright. I must be overriding it somewhere. Am I not? Oh yeah, I probably am during the update step. Yeah. Yeah, I do. That is why. No, that's fine. We have a secret text channel on the Discord server that you can use. Yeah, so we actually override it right here. So let's override the free floating camera for now. Instead, this is going to be reset. Because the Paul camera is kind of like bound to the transform of the Paul object. So let's try toying around with this instead. So sure thing. I'm looking forward to seeing that. Okay, so we definitely got the position change. Okay, let's see if we can succeed in compiling a matrix here where we simply look at the negative y here. No, that's black because let's see, up should be maybe -1. Let's try that and write just as is right there. Yeah, okay, that's better. So that's exactly what we want. That means that these parameters here are something that we're gonna use together with the lights here. Let's just move it outside of the scope here because we don't need it. Whoops. So we're back in this scope here, and let's overwrite this. So we need something like, well, the looking direction is actually what we just stored. The light direction is negative y, but, and our right vector, let's see, inside the camera function here, looking at up. Well, the right never really gets yeah, we changed the right vector. Did I mean, direction of look, -1, up. Not sure that I need to negate the position itself. Let's try. Mm, huh. Huh, huh, huh. Okay, let's just try binding the light position here as our camera view projection matrix. Let's see, data view projection matrix equals data light. There we go. Let's use that for now. Okay, so we get some kind of weird rendering. uh, yeah. Navigate. Yeah, so something's wrong here. Let's just hard code these vectors here. Instead, we do direction right equals why not? Exactly. That's why. Mm. Okay. Let's see. Okay. Let me think. Maybe I'm not translating this correctly. So, yeah, I'm not sure I'm actually. Let's see. Yeah, I think I need to rework my view matrix calculation algorithm. Um, okay, let me think. Let's disable this overwrite here. And let's just play around with what we are trying to do. Let's enable the debugging and let's move out to a free floating camera. So right now, forward is minus C, right is plus X, and up is positive Y. So if we rotate this like this, we will have positive X, negative C, negative Y. Well, it should be yeah, I think I need to redo my view projection view matrix calculation. Let's see. Let's just hard code it. View matrix calculation. Okay. Let's do that for now. Maybe it's more feasible. I'll redo this in another episode, I think, because, yeah, well, I need a more robust math method to handle it. Anyway, let's just set our view light equal to the first column equal to our This is the right vector x, which is 1. And then the next one is the up vector x, which is 0. And then the look vector x, which is 0. And then the position. Let's see. Our data lights 0 dot position dot x. There we go. And let's do the next one here. So this is the right y, which is 0, and the up y, which is also 0, but then the look y is equal to -1, and then the y position here. And then let's do like this. The c is 0, the up c is -1, and then this is like that, and then the c, and then we set the last column to be exactly this. There we go. And let's overwrite the camera information again. All right. Is it my let's just do 500 here. Maybe it's the far near planes. Nope. Camera. View protection matrix. Oh, maybe I need to flip the. Yeah, I probably need to flip the multiplication order here. Okay. I'm starting to think that we're inside some kind of object. Let's see if I negate this. Nope. Let me try and compare print matrix light matte view light here, and then print matrix cam matte camera controller get camera get view matte. Let's just do a print new line here. Okay. Cam matte 111. Let's override this, or rather stop this override and then adjust the okay. This is close to being positive. This is very small. This is also close to being positive. But this is negative. Okay. And then we have some position stuff. Oh, well, of course, the position needs to be rotated by the actual yeah. So let's create a rotational matrix here and then translate accordingly. So there we go. This is supposed to be 0, 0, 0, at least for now. And then we want a G vector position based math vec3 matrix. Let's see this and the view light here. There we go. And then we update the view light parameters. Position based. There we go. Okay, let's compare this. This should give us the correct matrix, I think. There we go. Yeah, it's almost the same right now. So yeah, but that one is still negative. Let's see. I'm pretty sure it's not supposed to be negative. Is it? Let's see. So if I look at things from this perspective here, one which equals kind of like that, and then this should be negative. It's of course in row order here, but they are essentially the same. Okay, let's flip these then. Oh yeah, okay. Yeah, now I know. I think let's see. Yeah, now the approximately the same except for the translation, which is off. Oh man. Well, it could be due to the effect that actually I raised the camera too high, but anyway, let's see. Maybe negate this. Minus 12. Yeah, it looks pretty reasonable. I'm definitely gonna update the algorithm itself for creating that view matrix. As far as I remember, it's also been bugging me since I created the application, so yeah, I should probably just redo it. Anyway, this actually results in a correct vector, or rather matrix. We don't need to debug that. We can skip this. Let's do like that. Compile, then run in RenderDoc. Let's see our depth view, depth buffer here. It doesn't show anything. Let's see. It will probably be mostly white. Okay. What if I set up this object in a different way? Maybe it's not. Okay, let me just select it. There we go. Okay, and let's do some depth buffering over that. Oh my god, I closed RenderDoc. Let's see. Let's do a capture. Oh yeah, my headset disabled. I'm sorry. Yeah, so we created our shadow map. Yeah, yeah, I think it disabled itself. I don't know what's wrong with it. It's only when I use the microphone that it sometimes just disables. Yeah. Okay, so we have a uh, 'yeah, I would like to offset the textures here. 14 constant buffer. Yeah, let's do 15 here. And inside our root signature, num descriptors. Mm. Mm. Maybe we need another root signature parameter here. Yeah. Let's see. Root signature SRV DirectX12. Um, set command list, set root parameter srv DirectX12. Let's see. Yeah, maybe we just want. Let's see. Okay. Shadow map. Let's see. Size of parameters. But this will overflow, right? Parameters 5. Let's see. AD 3D12. SRV, shader visibility, pixel shader. Let's see, shader register. SRV. Let's do it in another register space at least. Descriptor shader register. There we go. So we set our descriptor flags, I think. Yeah, none. Okay. Yeah, so the fifth parameter is our shadow map here. And maybe we want a specific descriptor. Maybe we want a whoops, null descriptor DirectX. Null descriptor. There's an article here. Okay, so we can try using a null descriptor for this, but I'm not sure it will work. Let's see, our program runs, or yeah, it does. Okay, so we've effectively created the last parameter here for the shadow map. Where we inside our pixel shader here, we'll have a texture 2D global shadow map register T1 space 1. Let's see. Okay. Let's see if we can bind the resource itself to our shader here without actually telling the pipeline what kind of descriptor we have here. Let's see. Yeah, maybe. Yeah, I'm not sure I actually am able to access it like that. I'm not sure. I'm not sure. Let's disable this. And let's just say that the first SRV itself is actually reserved for our shadow map here. Yeah, it'll probably be a bit messy, but we'll do it nonetheless. At least until I'm a bit more fresh and can get an overview of how to do things. Okay, so we will simply we will do a. Do we have render macros or anything in particular? Global settings, rendering, define, G, um, just disk, uh, disk, num disk, system, SRV, system. Let's set it to 1. So this was 14 plus the number of system descriptors. 14 plus, there we go. 0 plus this. Okay, the textures will be weird now. Yeah. Let's see. What's the error here? Oh, we don't get an error here. Okay. Yeah, I remember to, I forgot to set this back, so it's not related to our texture mapping here. Yeah, as you can see here, everything is messed up. Yeah, I should create a more dynamic system, but anyway. Uh, Inside our polygon drawing here, now whenever we create the resources actually, yeah, because the draw call itself, yeah. So whenever we create the object data from our add stuff here outside the application, inside the level system, load level, game objects, let's see, texture plus this, because the first ones will be hard coded. Let's see, so this should work for our default level. Yeah, except for the dynamic objects, of course. That's the static ones, right? Static. Yeah, okay, I do create poll and so forth. Okay. Yeah, I might redo this in the future, but for now we will do like this. And source code? I'm not sure I understand. Let's see. Yeah, I need to update the uh, textures, of course. So right now inside our level thingy here. So ID, mesh, material, texture. So no, I have a yeah, I do, but it's private. I haven't uploaded the source code for the engine here. All right, we fixed the texture. The first slot is now reserved to our shadow map. I think you would need an invitation, but yeah, it's not for public use right now. I do have a GitHub repo in terms of the tutorial series where you can look up the source code for that. Um, it depends. I think you will do a lot of typing if you do Vulkan. I think both are fine. If you're a complete beginner, I would do OpenGL or maybe DirectX11 instead. But if you are experienced in terms of using graphics APIs, I would probably decide based on what you like better and if you want cross-platform support. Okay, let's see. Are you sure you're live? I'm pretty sure that the YouTube chat should be live if you're live, and the restream.io chat is, of course, with some delay because it's always also showing the chat from Twitch through the restream layer, or rather, streaming service. Maybe there's a bit of a delay, but well, I have no delay, so it's probably the restream service that is slow. I have 0% drop frames and no latency at all, at most, almost. So, uh, but yeah, the restream service might be adding some delay, especially when I stream in full HD and 30 FPS. let's see. So we could create the SRV descriptor for the shadow map. Let's do a E3D12 resource. No, shader resource, view description, view disk. Let's see, view disk format equals DXGI format. So let's just copy this format here because well, if you really want to do the advanced APIs as a beginner, I think you should simply check out some tutorials on how to get started, and whatever you feel like is the most easy to digest, you should use, because the Vulkan and DirectX12 are highly similar in terms of what's going on under the hood, and at least some of the, or most of the API calls, although they might be abstracted differently. Yeah, I have I think it's 27 videos on a complete beginner tutorial on DirectX 12. If you know C++, you can follow that tutorial. It also has a GitHub repo. It will at least get you started. I implement a toon shader um, from scratch with planar shadows. Yeah, but here on the channel I have a DirectX 12 tutorial. You can see the end result in the last video, and the thumbnail of the tutorial series is used or is actually the actual renderer. No problem, man. I hope you find them useful. If you want me to adjust something in the future, let me know. But yeah, you could um, also learn Vulkan. It's probably more popular these days anyway. Okay, let's see, view description here. Data for component mapping, the 3D12 default data for component mapping. We have the format, we have the view dimension, which is going to be a texture 2D. We have texture 2D setup here. Most detailed MIP is going to be the first part of this. We are not gonna MIP it, MIP slice it, or rather one, give it more than one MIP because it's a depth buffer. Plane slice 0. Uh, 0. Yeah. Okay. So we create our our resource here. We should probably create the descriptor heap here. Yeah. And then we will ask our device here, would you please create us a shader resource view? We will pass it our DDS shadow DSS. Yeah, it shouldn't be named like that, but anyway. We will get that resource. We will pass in the view description here, and we will get our CSU heap here, get CPU handle, and we will specify 0 here. And we will create the first resource inside that table. Let's see. Removing device, the format cannot be used with the shader resource view. Okay. Can I DXGI format float 32 or R float 32, of course. There we go. Yeah. So it's because it's reserved for the depth stencil, but it's most likely the same resource. Okay. So now we bind our shader resource view, which means that right now inside our pixel shader, we don't need this anymore. But our first slot here will actually 0 will be equal to our shadow map. We can change this in the future and separate it into different, in general, I think we would like to be able to separate this shadow map plus textures. Okay. Let's see. My selection tool should be, yeah, as you can see here, the UI pipeline also needs to be updated. Anyway, I'm starting to consider that this is actually a bit silly. Yeah, this is actually a bit silly. Okay, I'll revert back. I immediately regretted this decision. So let's create another range here. Texture range. System texture ranges. Let's see. For now, 2 descriptors. Yeah, okay. Let's do a second register space. Yeah, and then this will be system texture table 0 equals shadow map. And this will be our pixel shader. And we will pass in the second range here, and we will increase this size here. This should be fine. At least if I haven't missed anything. Yeah. Okay, and back to um, the whole situation. Let's see, texture. Texture 2D. The shadow map. Register. T0 space 1. There we go. Let's go back to that because it makes more sense. We will still use this macro, but I'll just disable it in terms of cleaning up this code. So this part is fine. This part is also fine. But inside our level stuff, we shouldn't add that. Yeah. It didn't make sense. We would rather like to have separate. Yeah, of course I need to re-enable the macro because in the renderer it's referenced. And the let's see, did I not? So the problem is let's see, what if I load my default level here? Yeah. The problem is that we map actually to that specific index, which is also the texture index inside the renderer here. I'm doing the mapping itself really badly, I think. Yeah, wait a minute. Bind textures plus this offset here. Some of it looked alright. Let's see. Yeah, so we basically subtracted one we added before. 2 1 1 1 1 0 2 1 1 2 and 1. Let's see. Yeah, we're back. So we still assign the first descriptor to our what do you call it? Shadow map. but we bind it to our shader in a different way. This was the way that it's supposed to be. Okay. Then inside our draw call, we can actually, whenever we want to render this, we can set our bind textures. It depends on what you're linking. I don't know if auto moderation disables link posting by default. It might. It might. Bind shadow map. Let's see. There we go. So we have our shadow map. We have to force it to be a certain kind of descriptor. We can't just create a null descriptor. Also, let's see, inside our UI drawing here, we want to offset by our, let's see, UI drawing, where do we bind the texture? There we go, and plus this, there we go. Thank you very much. How nice of you to drop by, buddy. Uh, uh, uh. I mean, the text is now missing. Mm. Let's see. Oh, I of course can't remember which one is the texture one. Okay, maybe when I create the texture here, I forgot something. So the textures themselves, let me just think here. Inside our, uh, uh, yeah, I'm missing the fonts. Why is that? Hard coded to 15. Well, let's see if I just add maybe more to the 3. Maybe not 7 here. Maybe +2. Let's just try that manually. Nope. It's probably because we're overflowing. But I'm not certain. Let's see. Inside our root signature, material range. Let's just do 10. see 0 here. Yeah, we can't do that. What is the URL referencing? Maybe let's just do 1 here. And inside our renderer here. Ah, oh, that's the material. Okay, so we do texture 0, 1, 2, 3, 4, 5, 6, 7. So, huh. Okay. If I set this to 0, disable it, what will happen then? We will have chaos. Okay, now we're back to having text here. So somewhere inside the pipeline itself, I have a problem. So where do I actually use that value? Inside the initialization, I suspect. Yeah, but we could easily just increase that. But I would also do it here. All right, thanks for dropping by. I hope you will get started with your project. Seems like a nice project. For some reason, I'm ending up in a situation where I do not. Okay, let's try enabling this again. Um, so it's related to the way that I bind the resources. Whenever I am I overwriting it somewhere? Let's see. Inside the UI rendering. Pixel shader. We simply map onto a simple texture 2D here. We expect the first texture inside the table to be well. Maybe it's the way I increase the pointer, no? Anyway, I'm gonna look up the actual descriptor table here. Let's see what's happening. Descriptor heap. Descriptors 14. 1. Yeah, of course I overwrite it. Yeah. Okay, let's try hard coding this. To 15 and then number 14 here gets bound to that. Render doc. Resource inspector, descriptor heap, 15 descriptors. We have that resource there. We have a shadow buffer. I think I know why it didn't work. I'm pretty sure I end up overwriting the thing. So we can revert back. Let's do that. It's because I overwrite the descriptor. It's it ends up being out of bounds because yeah, we enable that. Enable that. Okay. Let's do this again. This again. And then create material data. There we go. This should be fine then. Okay, let's try the default level because, well, the text is fine at least. Also, we want to offset the materials, of course. Materials, shadow map, plus this. There we go. All right. Next thing. What to do is, well, let's see. So inside here we calculate the temporary matrix. We send the frame data. We don't need these shaders right now. We don't need the global settings, but inside our update step, yeah, we could simply instead of this, we could simply add to our pass data, our shadow pass thingy here. We could do we could do. Yeah, so this ended up being quite circular. Anyway, it is what it is. Let's see, we will add that. Let's see, we will ask for our data lines view projection here and simply copy that. Because now past data will simply contain the view projection matrix as well for the thingy. Um, what do you call it? You call it uh, I'm really tired. The view projection matrix for the light source, which gets uploaded to the shader. So now we can take our default shader here, and inside shared, we will have some past data where we will have a float 4x4 lights view projection array. We bind that to our shader. Then of course our vertex shader here needs to compute the the let's see, I think we should bind the hi. No, I can't claim that. Uh, Hello, how are you? I'm unsure whether he's AFK doing something. That's great to hear, man. I was actually contemplating ending the stream for today because um, what we have left is programming the shader itself to actually draw the shadows. Aren't you supposed to declare a friend class of sorts, or well, I can't remember. I mean, the inheriting object should have access. I'm unsure. Derived classes, member variables. Yeah, you probably can't, can you? Yeah, it's probably because of the way that the pointer stuff works with classes. Did you set your class definition of the derived class to public? Sometimes I forget that, and then all hell breaks loose. But did you set your did you set up your inheritance correctly? Because once your inheritance is correct, it should just be able to access its own member variables. Okay. Well, it should have access to the base class member variables if they are protected. It should just be the dot operator, I think. It shouldn't be the pointer. This is a pointer, so if you access it by using this, you would have to use the arrow stuff. But basically, you should just be able to access the member variable directly. Inside the class itself, the derived class, you can type out the names of the protected member variables. It should inherit them as fields directly, so there should be no need for the pointer stuff. All right, so our program is doing what it should. We have the shadow map buffer being generated as it should. The depth buffer is fine, and therefore, um, let's see what happens if we access it as a. Well, yeah. Um, it will look better when the actual shadows get rendered, but I'll do that tomorrow. I'm way too tired today to do anything that requires any concentration at all. Uh, Yeah, so yeah, I'll think I'll have to go too. I'm too tired to carry on. You too, buddy. I'm looking forward to that video. Um, yeah, as I've started, as I've mentioned in the start of the stream, I'm really mm, mashed. Thank you, thank you. I'm glad you liked it. It's definitely gotten better, but I think there are still improvements to be made. But yeah, hopefully I'll get some more interesting footage to show during the next devlog. Yeah, take care, man. Have a nice one. And yeah, to any viewers watching in the future or who tune in lately or recently or who just tune in, work has been really rough this week, so I'm extremely tired. Yeah, I can't really focus today, so I didn't have high ambitions for this stream, but I think we at least got a pretty good way towards rendering the shadows. Um, the only thing left is to set up the actual shader um, themselves and maybe upload a few different parameters, and then we will be able to render shadows for our lights. And of course, we need to do some optimizations in terms of the math algorithms for the view matrix calculation for random light sources. But yeah, we'll fix that. Anyway, um, it depends on what kind of math um, we're doing. Um, some things are faster to compute on the CPU side and upload to the GPU instead of doing them over and over on the GPU. So mostly I do math on matrices and stuff like that on the CPU side. Well, it would, but you would have nowhere to store them. The output of GPUs are generally large arrays, either textures or 3D arrays. Um, so pre-computing, uploading and pre-computing. Well, I'm not sure Um, yeah, it does. It's not effective. Um, it's way faster to do matrix computations, the base matrix computations, and deriving on the CPU side. Besides, the CPU side uses these. It's in 3D graphics, it's only 4x4 matrices. So, and you don't do a lot of matrix computations on the CPU side, but you pre-compute the actual matrices themselves on the CPU side usually, and maybe you do one or two multiplications here and there, and stuff like inversing the matrices or transposing them or whatever. But imagine that for a vertex, you need to do a point times matrix computation for each vertex. Um, that is why that part is way faster on the GPU, because there are so many vertices and so many vector times matrix computations. But as far as the CPU side, there aren't that many computations. It's pretty straightforward most of the time. Only physics do a bit of a heavy math, but generally, yeah, it's so lightweight in comparison to the GPU. So besides storing the information on the GPU is really yeah, mostly, or just computations on a lower scale. Yeah, yeah, it's because of the scale that you let the GPU do stuff like that. It's really efficient at doing, for instance, 1 million vertices times the same matrix. It's really fast at that compared to a CPU. But once in a while, the CPU is fine just doing a few multiplications here and there, as long as you're not supposed to do a lot of the heavy lifting. Anyway, buddy, it was nice to see you here on the stream. I think I'll be going since yeah, I'm really smashed. Uh, I can't really focus, and yeah, I need to chill a bit. Take care too, man. Have a great one. Catch you later. And to everyone else, bye bye. Thanks for watching.